It wasn't great.
It was fantastic. I don't know.
All right. Hello, everybody.
Jesus.
Welcome to our club meeting of the Data Science Club.
Stop speaking so loud.
I told you, I speak loud.
Okay.
Yes. We have our president here, President Travis.
Hello, everybody. I guess that's him handing it off to me. And I have a mic. Cool. All right, so we're doing the Data Fest. We talked about that. We actually have a flyer. Don't copy this flyer and print it out. If you want to help us out, there's the real flyers out there. It looks nice. But yeah, if you want to scan this one, and you can join. It's April 14th to the 16th. All right. That's going to be cool. We'll continue to be talking about that. A lot of the things we're doing today and in our future meetings until this occurs is to prepare for this. So it's kind of like one of those things like, why are you coming if you're not going to this? Also, it's like we're first telling you guys before everyone else gets in, because I think we're limiting it to some amount of people. So yeah, with that, I think Jeff can just go.
Yes, so I've shared my screen. So if you guys look into your Discord, you'll see a notebook posted. That'll be the notebook that we'll be going through for this workshop here. It's going to be some basic info on natural language processing and the likes. All the resources that we'll be seeing here will be on that notebook. You could download that notebook, make a copy of it, whatever you want. And that'll be some useful stuff, especially for DataFest, because we'll need to be using some natural language processing. So, as we get started, I'd like to ask how many of you know what natural language processing is? Yes. Good, one person. Yeah, thank you. Thank you, very good. So, it's all good. We have no knowledge, so that's a good thing. We're here to learn the basics, to get a basic understanding of the things, to get a real sense for it. So, we're going to talk a little bit more about natural language processing, how we could do it, especially in Python. We'll look at some examples of coding. We don't have too much code here, but we'll look at some examples, and we could use that in the future for our future code in natural language processing. So basically an overview of what we're going to be going over in this workshop. We're going to be going over the goals of what natural language processing is. We're going to be going over fundamental concepts, a lot of terminology that you need to know, not too like mathematically into what natural language processing does, but we'll go into a lot of that, just the fundamentals about it, and specifically, and we'll look at specific natural language processing techniques that we could use in Python specifically. So the main goal of natural language processing is the problem with language is that language cannot be processed by a computer directly, and so we need to make language something usable for a computer to, and for our data analysts to be able to use. And with language, there's a lot of context, a lot of meaning, and a lot of things that could be embedded within language. And we want to be able to extract as much of that meaning within the language as possible. Because like, when I'm saying a sentence, it's not just I'm saying a words. Those words also have meaning, and there could be some underlying context between what I'm saying, and that could also have some other meaning, and we want to be able to extract that sort of stuff. And so this is basically a sort of way to do feature extraction and to be able to make language something into a data processing thing that we could be able to use. So if we look at natural language processing and like some of the applications, some of the big ones here is like ChatGPT. Everybody's heard of ChatGPT, right? Yeah. The other big ones too is sentiment analysis. Now, what that means is that with sentiment is like basically what is your sentiment sort of towards something. Like for example, in a movie review or a business review, we want to extract basically what's the sentiment from that review, and that's one of the big main features of natural language processing, and being able to extract sentiment from the words that they're saying rather than just if they gave like a 1-star or 5-star review. We want to be able to do stuff like extract that sentiment. Other stuff too is like language translation. Historically, one of the main reasons for driving natural language processing was actually through the use of wanting to be able to translate from English to Russian within the 40s and 50s. And also other things too, you would see like in your everyday use, like other chatbots as well. predicting what your text is, your Google searches, all that stuff, and filtering emails, being able to classify things as well through text. So these are some of the applications that we see with natural language processing being used. And there are some fundamental concepts that we need to get first before we go into any of the natural language stuff. So the first concept that we need to know of is a corpus. You'll hear about a corpus a lot. The plural is corpora, but all that is just it's a collection of documents. What is a document? It's just a collection of tokens. And what is a token? It's just a singular word. So this is our structure of how we are able to store all of our data and use it for future natural language processing in other tasks as well. We basically store, and our documents are just like, could be a single line of words, or basically like something that you see every day, like maybe just like a header of like a news article or something like that. That's what a document is. And within a token, there's different things that you could have within a token. Typically, the most case, it's just a singular word. It could have punctuation involved, but usually that sort of stuff wants to be taken out as well. And there's also, we'll go into a little bit about linguistics, and even though this is not an English class, there's some stuff we have to know about language in order to get, because we have to do also a lot of pre-processing with our data first before we want to be able to do anything with natural language processing. So natural language processing is a very large field, and it's a combination of many things, specifically computer science, human language, AI more recently. However, this one's like sort of missing a few things because it's also a lot of what to do with statistics as well. So there are also many types of natural language processing that we'll take a look at. We'll mainly look at statistical NLP and neural NLP. Now, symbolic NLP is the more historical natural language processing. That's what stuff specifically with language translation as well. And how it works is basically just applying rules to language. It's a much older stuff, less complicated, but it basically worked on being able to set these complicated sets of rules and being able to parse text through that. Now, that was basically what was around for natural language processing from the 1940s all the way up to the 1980s and even up to the 80s. When you get to the 80s, you'll get to stuff like the statistical NLP. That's where you start to see unsupervised learning algorithms and semi-supervised learning algorithms, where they use statistics to be able to make some sort of inference on the data of the text. That's where you start to see like stuff like chatbots being able to pop up and such like that. And then within the recent decades, within the last two probably decades, you get the neural networks in natural language processing, especially with representation or machine learning. And deep learning, we'll go a little bit into transformers. So I'm not sure how many were here last semester, but we talked a little bit about transformers. But we'll go a little bit into how transformers work. But transformers is a big technology or the architecture that ChatGPT uses to be able to make such good responses to your questions. And if you want to look further into the different kinds of natural language processing, there is not that much that we'd be able to cover just within this one workshop, but you'll be able to see all the historical types of natural language processing that there have been and how they could be used. Now, and also another important topic to go over is tokenization. So with natural language processing, we first have to split up the text into tokens. Usually all that is just like separating the text into the white space, based off the white space, get rid of all the punctuation, get your tokens, and that should pretty much be what you do. But that is generally the first thing that you would need to do for natural language processing. Now, the next concept that we need to go over for natural language processing is stop words. So in language, there's a lot of redundant words that we don't really need to use. Like, for example, and, the, to. Those don't really give us that much information on what we're wanting to do in our natural language processing tasks. And a lot of time, our sentences will be filled up with words like that. Like, you will see the like a million times in your essay, and that doesn't tell anything about your essay. Just you use the a lot of time. Like, those kinds of words we need to get rid of. Now, with a lot of the natural language processing, they do have libraries that have all these stop words in there, And you could also create your own custom stop word list if you want to filter out specific words. Like if you were talking about, for example, looking through movie reviews, you're obviously going to see the word movie a lot in it. So you could probably add the words like movie or something like that, or film to it, to probably add to your stop list to create a better word list. Now, generally, all you have to do is just filter out the stop word list from your data, and that's just one more step that you need to do. Now, why it's useful is that it gets rid of the less important data that we need to use and allows us to have more focus on the more important words that are in our sentences. Like, let's say a sentence like, the cat jumped over the tree. We could probably shorten it to cat jump tree, and we'd still get the same context from it. That's a similar reason why we're doing it in natural language processing. Now, the next thing we need to know is about normalization. So within words, there's a lot of like different variations of words. Like I ran, or I was running, I will run, or whatever the prefix was it for that. Yeah, same thing. But there's a lot of words that mean the same thing, but would be spelled differently. And we have to normalize our words to make sure that we're able to group the same words together, because you don't want to have like different words all like spread out together. Like for example, studying and study, or studious. Even though like those are all different words, you sort of want to be able to group those together into something very useful for your data analysis. So there are two main ways that you could sort of be able to do this. The first is through stemming, and what stemming does is basically gets rid of the ending of the word. Now, this is able to help in some ways, but there's some ups and downs to be able to use stemming. So stemming, all it will do is just get rid of the ending, because most of the time the words are affected mainly by how they are ended, and so getting rid of the ending is basically able to combine them together. The other way is lemmatization. Now with lemmatization, it's basically taking the word, whatever it was, back to the root word that it was originally. So like running would turn back to run, runs turns it back into run, ran back to run. So yeah, that's a little bit about English, but yeah, stuff we need to know for natural language processing. So we could use either one of these two methods. They both have their ups and downs for being able to use them. But ultimately, we want to be able to use one of these two methods to be able to make our data more efficient with our processing. Now, the next thing we should look at is what's called the bag of words model.
So the tenses of words?
Yeah, that's one thing too. And like, I didn't like do much English stuff, but you know, like when a word becomes an adjective or a verb or that thing.
So like change its type. Okay.
Yeah, that stuff.
Bag of words.
Yeah. So, on with that. The bag of words model is another way that we could represent our natural language processing text. So in this, what the bag of words model is that basically it takes out the positioning of the words and the occurrences of the words and turns it into basically a frequency table. So, for example, what the bag of words model would do, like for example, these two sentences, John likes to watch movies and Mary likes to watch movies too. Mary also likes to watch football games. These are two different documents. In our bag of words model, what it'll do is it'll basically transform it to a frequency table of what the different words are. Now, there are many ups and downs to be able to using this. It's very data efficient or memory efficient too, but we don't get any positional context to any of the words. We just know something about the frequency. This might be useful in some situations where we don't need to know about the frequency or the location of the words. Rather, we just need to know about the frequency of some words. So like, for example, if there were a lot of words like that were very emotional, like a lot of words related to love or related to hate, we could be able to use a bag of words model to figure out which ones are correlated more to love or hate and how much they're used more to see whether like the comment was something lovingly or hatefully. So that's the idea behind the bag of words model. The other model that we could also look at is the TF-IDF, or also known as the term frequency, inverse document frequency. This looks like a bunch of complicated math, but basically all it is it's just a really fancy computation. And what the TF-IDF is is basically figuring out the term frequency. So what this is basically, it basically gives a score to all of our different words in our document, how much they're used in our document, and what we're able to use this is to be able to determine which words are the most important words we want to be using. So even on top of stop words, we still want to reduce the amount of words that we want to be using with natural language processing. And TF-IDF is one way to do that. So it basically uses these two computations, the first being the frequency of the term in the document, and the other being the inverse document frequency. What the inverse document frequency is basically allows us to, even though some words may be more frequent, basically determines their usefulness. So like, for example, words like the may have a high frequency, but the inverse document frequency will lower that frequency for words like the to something less useful, because we notice with the inverse document frequency is that that word is seen as something less useful and less important to our corpus. And with this, we're able to basically calculate the score for all the stuff within our document, and with that, remove the words given a certain limit, and maybe give like the top 20 or 100 best words within the document. That way we're able to have much less words within our corpus and be more efficient with our text. And on with that, that is all of the basic terminology that we need to know, more specifically for natural language processing. We'll go a little bit more into it when we go into the natural language processing techniques. So now we'll go into some of the stuff related to actual natural language processing. So first, the first thing that we want to get sort of a sense about is regex, or regular expressions. Or is it regex? Regex.
It's regular expressions.
All right, yeah. Well, actually, yeah, that sounds more like regex. Yeah, don't call it that. Regex is something that is very useful, but the main point of it is that it's simple, powerful search patterns that we could use for our text. There are many methods that we have in Python that we could already have that already come with the basic Python. We just have to import the library. But there's a lot of stuff that you need. There's some stuff that you need to know for regex, and so there's a lot of basic characters or things that you need to know within a regex to be able to use them. And there's many things that you can add onto it. But the power in regex is that it's be able to search. It's be able to abstract or make abstract different patterns and be able to search for those rather than just search for like a plain word like the. It could be also be able to use to be able to search in a more general sense depending on how the regex is created. So we'll take a look, at a little bit about some of the stuff that you're able to do with it. So the main important ones should be these quantifiers and the characters and the logical operations. So for example, if we have this, this OR here, so when we create a regex, basically it'll look just like a regular piece of string of some sort. If we wanted to say like this character or that character, like A or B, a lot of this stuff has overlap with CSE 135 for those of you who have taken it. So like if we wanted a regex that looked for either the letters A or B, we could do something like that. So you could also look more into what's on the regex cheat sheet and sort of use this stuff to be able to build more complicated ones. And you could even, there's a really common one, especially for emails, that's probably somewhere out there on the internet. But with these, you could see all the different examples of how to use these different expressions to create your regex expressions. And so we'll just look at the regex library within Python. So here we just run it to import it. So one of the most important functions within the regex part is a search. So in it, it'll basically search for the first occurrence of whatever's in the text. Now, this regex expression is caret the dot star Spain dollar sign. Now that's a lot to unpack right there because that's very complicated one. So I'll go over through the symbols of what's in this regex expression. So the caret is basically saying match with the start of the document, whatever follows after it. So it's matching for wherever there's a the that starts. And the dot is basically a character that could mean anything. So it's looking for the and then just any character afterwards. The star then means that repeat the last character as many times as you want. So let's just say we took out the Spain and just left it at that, and then it would basically match the whole entire string. Now if we kept the Spain back in, it basically would then, no. We need to put the star back there. No, there. We put it there, we see it still matches, but then it'll stop at Spain. But then if we add something here, it won't go, it'll just stop at this last Spain. And so the final character is the $sign. And what that's basically saying is just match whatever's at the end. So if we just said that this was an A, we're expecting it to end at an A. So then it'll return the whole entire thing. Now a thing to note about it is that this only returns, the search function only returns the first occurrence of it. So for this example, in this one, we're basically searching for a regex where there's an I and an S or an N. What the brackets means is that it's basically saying it has to match at least one of these. So it'll return this first is in this. And so it won't return any other examples of is or in this sentence. So now the final, or the next useful function that we want to be able to use is the find all. And now what this does is it basically just gets all the different search results from your regex expression. So from this is either searching for an uppercase or lowercase t, any letter, and then an e. And so from that, it's returning all the occurrences of where those are occurring in this, though you won't get any positional information about that stuff. And then the next function we want to go over is the split. And the split, so we'll just use the same regex pattern, but it'll basically just split up the text into with whatever the regex term is. And this could also be useful for tokenizing your document. As seen here, if we just tokenize it based off of the space, we're able to split it up to all the different words individually and return it as vector. Now, one more thing with the, what was I going to say? Something about the split, no. So it's all about how you also just be able to create your different regex expressions, and as well, there's also the ability to be able to substitute in for wherever your expressions are. Now, so for example here, we're just saying the same expression and replacing wherever that occurs with the word foobar. And so the power with these regex expressions comes from basically being able to create generalized expressions and be able to make them abstract rather than just specific words. And that's the power that comes in with regex and how to be able to use them. Now, so the next thing we'll look at, and finally, if you do want to test out your own regex expressions, there are online stuff that you could do where you could insert your own regex expression and test it out on a string to see where does it recognize your expressions and did it actually recognize them as well. Next thing we'll move on to is NLTK, which is the Natural Language Processing Toolkit. So this is basically the standard library for natural language processing in Python. It's probably the most important part of this natural language processing part, and we'll see how to be able to use it within Python, or we'll look specifically more in some of the examples within Python as well and look at some of the documentation. Now there is a lot that you could do with the natural language toolkit, but we'll take a look at some of the most important ones. Are there any questions right now?
Does this involve database integrations?
Does this involve database integrations? No, unless you are wanting to some way be able to use this on a database, But in the case of statistical computations, you'll mainly have all the data on you probably loaded into memory already. This could be used for database engineering and the such, but there is some overlap with it. However, we're looking at it in the sense for statistical computing and data analyst in the sense. So I think that should answer the question. Yeah. So we don't have much examples here, but we'll look mainly at the documentation of the natural language toolkit. Now this basically has a whole bunch of stuff that you could do within Python, and we'll look at some of the example usages that they have and how it's able to basically use what we basically looked at. So probably the most important ones that we'll look at is the classify ones. The classifies with this basically allows us to classify things based off of what the text we give it and be able to classify into different categories. So there's a whole bunch of different ways that things can be classified. Main ones are specifically through regression, native Bayes, decision trees as well. All these different statistical computations could be done through the natural language toolkit, and these are all different examples of how they're able to classify and be able to train these models. So that is just one of the important parts of the natural language toolkit. Another part should be probably the corpus and how to be able to access it. So yeah, we could also take a look through more of the documentation and see what it's able to do. But with this, we're able to see what we could do with the natural language toolkit and what it's able to do. So with this is pretty much with this one, it should just be able to, how are you managing your corpuses and how you're able to basically be able to access certain parts of the data from the corpus as well. And as well, this is probably where you would want to be doing those, the pre-processing on your data as well from this natural language toolkit. And so yeah, that should be what you need to know from the natural language toolkit. And we could always go look at it more in the future. So now, moving on, neural networks. So, big thing with natural language processing that's been in the recent last 2 decades has been the use of neural networks to basically use to be able to do the same task that we want to do in NLTK, but this time with just neural networks. So with it, it does require using a lot of text in some cases as well, but they're a lot more powerful in what they could be able to be done. You've seen especially with stuff like ChatGPT and the likes. And so we'll be looking a little bit at TensorFlow, even though we mentioned we want to look more at PyTorch, but nevertheless, they still have good cases of examples of neural networks and being able to use natural language processing. So a good thing with the TensorFlow examples is that they do have a lot of notebooks that you're able to look at and be able to see what it does, to be able to get examples on what they want to do or to do it specifically. And so we're just able to open them up. So with this one, this is just a basic neural network to be able to classify movie reviews. And they use the IMDb dataset, which has about 50,000 movie reviews. So you always need a large amount of data for your training if you want to be able to use the neural networks. And from this is just some basic setup stuff here that they end up doing with the code. And then they also have since it's an online thing, that you are able to download the data set from there, or from TensorFlow, since it's already published, I believe. Yeah. And then you're basically able to build just a basic model as how you are for any neural network. Everybody here have some experience with neural networks, or yeah, just a tiny bit. Though we could go over, yeah, neural networks in the future as well to be able to get a more sense of this. But I would say this stuff is a little more of the advanced side and not entirely what you need to do to be able to get the bare minimum for natural language processing. That'll mainly be done through NLTK. All right, well, this is taking a long time to download, so we'll just skip over that part. But basically what we're able to see from what they've done before is that the code for building the model is very simple. They just have a very simple model. This is pretty much all the model really is. It's just a few layers of a neural network, and then they train it, or compile it right there and train it. And with their accuracy, they're able to, let's see, this is about how much accuracy that they were able to get with their model that were given. But that is just a training data set that they use. So let's see. So, and with the loss, they also got pretty low on the percentage too, but we aren't able to like see exact values for that. And the other model that we sort of want to look at, be able to do it, is BERT. So now what BERT is it's a transformer architecture. So with the transformer architecture, basically what it is a transformer architecture is able to process sequential data, which is why it's very useful for natural language processing. But unlike other sequential data processing within neural networks, this processes it all at once and is able to do work very efficiently at stuff like task translation and summarization. And it's one of the things that you want to look at specifically more if you want to look into more about ChatGPT and how that works. Definitely look at the transformer architecture. There's a whole paper on transformers as well that you could read. But that does require a little bit of info or introductory knowledge into neural networks and how they work. But with that, that is basically how pretty much what we're able to do with neural networks on natural language processing. And the last few things we want to talk about a little bit is the important. Do you have a question?
Just to, I guess, a quick reiterative summary, like that it really depends on the job that you want, knowing what model to apply for the job sort of thing.
Yeah. Yes. Or as I mentioned before, with the different applications of natural language processing, it's very important to figure out what your task is going to be doing, such as like email filtering or chatbots are very different things, but we want to be able to, oh yeah, you weren't here for that part, yeah. So it all depends on what you want to be able to do with your natural language processing and how you handle that data. This is basically just a bunch of tools to be able to get to that stuff. And so that's also why you want to have a good understanding of what your task is that you're wanting to be able to do. So that way you're able to know which natural language processing tasks you want to be using and what's best for your case. And so finally, we'll just talk a little bit about data visualization. So we have all this data, but an important thing to note about natural language processing too, and especially for the data science, or not data science, data FES, is that it all depends on how you model your data. So something to consider with the natural language processing too is how you model your data, how you visualize it to the judges, because not all of them will have like experience as much as you have in natural language processing or other statistical methods. And it's also important to know how you present your data. So that's also some important. And finally, we'll just talk about GLOVE, which Travis will take over for that. Yes.
No, I'm just gonna like literally
Yeah.
take over. Oh, does he have a mic on him?
Yes.
Oh, I didn't realize.
Or you can just talk really loudly.
No, it's fine. Okay. So what's up, everybody? So I'm actually gonna, before I talk about GLOVE, I wanted to talk about just like the neural network stuff real quick too. So I've been like working on some projects, and I've been using some models like these, and I just wanted to like say that's like you can use what's it even called, the NLTK library. That's like the really like you're not using neural networks. It's just hard coded things. Those are really efficient if you're just doing something quick. You don't need to go train a model for. If you can't find a model or it exists, things like that. If you're working with a big data set, that's where that's really useful. So like that's probably going to be the most useful probably for the DataFest, where you could use something like BERT. BERT is useful because it's going to get you encoding. So if you're trying to see if like a sentence is similar or something, you could do that. But it's going to involve more work. So like when you're in the DataFest, you're not going to have all that time to like train a model and set everything up. You might have if that's like actually needed, but it's one of those lower priorities. And then one last thing on the data visualization. Who knows what the DataFest exactly is going to entail, but a really nice way to visualize words is a word cloud. And so I don't actually know exactly how you could make it in Python, but you could Google it, and I'm probably sure you could find out how. In a word cloud, just like based on how many times that word occurs will like get bigger, and you can even do things like if you were doing sentiment analysis, the bigger words will like be a different color depending on the sentiment. You can do all these types of cool things. It may take some work to make that visualization, but that is a very nice visualization to make if you're dealing with words. Okay, now
I'm not saying anything about Python though, but R has it built or like a library for it.
Yeah, we did that in 128.
all right, so Glove is basically what we used before we had. Wait, is there the URL for it too?
Yeah. Oh wait, it's not a touchscreen.
It should be touchscreen right there, man. All right, let's see if I can find it.
Man, we're Apple users.
Do you have it reversed?
Yeah.
See, that's why I said up.
Oh,
That's why I said scroll up earlier.
okay. That was
It's
really
logical.
All right, so Glove is really useful. It kind of starts to get it. So you have that NL, that neural network, what's the
NLTK.
NLTK library. That is useful. It has like all the hard coding things. But if you want to get into more like the statistical and like almost like neural network type of things, Glove is like that beginning part, like just that little level before we got BERT and all these crazy things. And it's really useful. I actually use it for spell correction. I have like for one of my projects, I use it to correct spelling errors by trying to find which word is the most relevant in a certain context. I actually forget exactly how I use it, but Glove gives you an embedding, like several, I forget exactly how many numbers. It's either 128, 256, or probably says somewhere here, or like 512 numbers. Dimensions, 300. That's what it is. So it gives you 300 numbers that represent each word. And these words are like, these embeddings are like smart embeddings in that you can do things like subtract like man from queen. So if you take the queen embedding and you subtract man from it, you can get like, or if you take the queen, subtract woman, and plus man, you can get king out of it. Like they like have an understanding of what words mean what in like a given context. And so that's really useful if you're trying to like build, like if you were to also like cluster these and like build it, you'll find words like coming closer together. So like in this example, like sir, king, and man are kind of like close together. And so you can basically get like an embedding for words. So if you're just wanting some quick way to embed words to get a word by word understanding of words, then you can do that. It does not, however, like it's not really useful for sentences. And so that's where BERT comes in. But this is useful just if you want to do some quick thing. Like I mentioned, I didn't want to train a model. This just gives you word embeddings, and if you do some statistical thing with it, you can just do it without training a model. So that's where I just untied my shoe. This is where this is useful. Okay, were we on this one?
Yeah.
And then BERT kind of takes the Glove and says, that's cool, you did all the statistics, let's just train a model. Thank you. And BERT makes encodings that are dependent on the context. So these, like that immediate context. So the Glove's embeddings, although they are trained and like dependent on the context that those words were found, it was trained in that if you were to give it a sentence, each word only has its like, that embedding is the same for the word every time. But in BERT, if you were to read a sentence that used the word hello, and then you used hello in a different, like that word in a different context, it will give you a different embedding for that specific word. at least in that segment. So it embeds, it has an understanding of that whole sentence. So that's really useful for words that are like the same word in English, because in glove, it's just going to say, this is the embedding for it, that's it. But so it gets confused. But in BERT, it will be like, oh, based on the context, they're using this word in that way. They're not using it in this way. So it can actually get a total different understanding of each word based on its context. So that's really useful. And then I don't think I have too much more on that. That's basically BERT, and I keep touching this like it's my laptop. Okay, and then that's basically it for glove and the rest of that. I will answer that question in a second. The last thing is that we will be talking more on like ChatGPT, BERT, and actually using those things in hopefully a later like workshop. And also we'll try to get a little more hands-on with the NLTK library. For now, it's just like telling you it exists. If you're trying to do something along those lines, if you're trying to practice for DataFest, whatnot, that's probably the library to go to. And then there's, I think Jeff was using TensorFlow, but if you go to Hugging Face, you can find many models. And if you like are searching for one and you don't know where to find it, you can ask me. Because there are models that deal with a response. So if you want to say something like, hello, how's your day? And then it will say, oh, my day's good. I just got off of work. Like if you wanted something like that, you can, there's models that exist for that. You can just download and run. If you're wanting a model that translates from like English to Russian. There's all these things that exist. On Hugging Face, you can use TensorFlow or PyTorch, and they're very easy to just get working, so long as you have TensorFlow or PyTorch set up. So if you use PyTorch, it's really easy. All right, that's basically it for this. Did you have anything else, Jeff?
No.
Okay.
Unless
cool.
you did.
I don't have anything else.
Yes.
The question. What was that question again? I didn't answer the question.
Here, you want to read it?
I'll just read it.
Any questions, guys? Cool.
Oh, so the resource that you
Oh, I see
posted,
it.
Yeah.
Oh, sorry.
Which one?
well, just the resources that you're posting in the, like most recently,
Yeah.
those will stay up, right?
Oh yeah, it's all uploaded on the Discord. You could see it in,
Like come April, we could reference that.
yeah,
Okay, cool.
in the learning resources. Yeah.
For sure.
Download the notebook. There's also a whole bunch of links on there as well. So yeah, all that stuff will still be there for the years to come, probably. As long as the server's still up.
Yeah.
We'll try to keep it up.
So just to answer a couple questions, we got one question about the model being like a center model, like deep learning around the cloud. So I'm not sure the exact context when that question was asked, but for the most part, there's two services. There's cloud services where like you could do this. Like if you're wanting to use ChatGPT, there's APIs. I don't know exactly how easy that is to get actual ChatGPT's APIs, but there are APIs that you can get access to do like cloud natural language processing and things. There are also local models, which I just mentioned, where you can just go to Hugging Face, you can download one and run it on your own computer. You may or may not need a GPU, but if you don't have a GPU, you can actually do it on Google Colab, so that you'll have to be doing it not on your actual laptop, but it would allow you to get access to a GPU if you didn't have one. The other question was, so we were talking about, this question was about trying to get into the level of ChatGPT or lower level chatbots. So this is like, how advanced chatbots are we working on if we were to do one, I think, was the question. And so we were talking about using the NLTK. That is going to be like lower level. You're hard coding things. It's a lot more work. If you wanted something like chatbot, like a ChatGPT, where it's more so just was trained on the data, that's where you're going to have to probably use a neural network model, and you can download those on Hugging Face or use an API. Okay, I think I answered those two questions. Was there any other questions?
That was basically.
Okay, cool. All right, any other questions from y'all or in the chat?
Any announcements?
Oh, redo that.
Well, to redo this. Well, first, is there any other questions before I announce and kind of change topics?
Is there going to be a voice recognition workshop soon?
Voice recognition workshop. No, but if you want to be able to do it, I can easily show you how to do that.
You just use fast forward transfer.
No, it's harder than just that. No, like if you're trying to train one from scratch, yes, you use a fast Fourier transform, and then you would train it. I think that's normally how they do it. But that's normally I just leave that to other people and just download their model to use. So yeah. What? I used to see. That's not my personality. My personality is like
What?
you see code it, do it all yourself, and then I was like, oh, I don't have $1 million to train a model. I guess I'll do it.
Well.
Yeah, why fix it? Oh, well, actually, it is broken though, because at least the current speech to text and text to speech model I'm using is under the Creative Commons restricted license or something. Basically, meaning you can't make money off of it. So that's like lame. So someone should go do it and release it as an MIT license. Okay. Just re-announcing the Data Fest. That is April 14th to the 16th. You can join by just scanning that QR code. Hopefully it actually scans. We will actually put the link in the Discord at some point too. Hopefully I remember to do that. Is that gonna work?
Yeah.
I doubt that, like especially because there's so many QR codes. You probably just need to get up close to it.
No, it works.
Okay.
Cover it with the hand. Yes, it works.
All right, we have like 10 more minutes left of this meeting. Any questions, off-topic questions, anything before we end? Why are you zooming in my face? Okay. I have a. Any other questions?
I guess this is just kind of off topic, more generic. So like, I've been learning R in more detail recently, and it uses like data frameworks instead of like data structures that I'm more used to, like the heaps and all that fun. So then, just going back, kind of remembering to some degree what we've done, what we've looked at, and these, I guess, call them like workbooks or notebooks.
Notebooks,
Yeah. Is it like the same idea? These are like, this is working with Python using like data frames?
Yeah.
If we're using pandas, we're working with the data frames.
Okay.
Yes, pandas is like the main thing for data frames.
Gotcha. And then, but if we're using other stuff, it's different structures?
So like NumPy would be like 2D arrays or ND arrays. If we're using pandas, data frames or series. If we're just using pure Python, then it's like it's going to be like objects and stuff, not data frames.
All right, so we do have one speaker on March 3rd for data analysis. So if any of you are interested, it'll either be here, same time, same place, or it's going to be in the Union if we can get pizza. So if you want pizza,
Raise your hand.
yeah. All right, so I'm going to try and lock down the Union room so we can get some pizza going. Where from? It's going to be from 3 to 4, March 3rd, from, yeah, same time, same different place. But yeah. Any other things?
How's your day going?
Good. Good. All right. In that case, woo! Thank you everyone for coming. See you guys later.
I guess I'll have to leave then.
Bye.
All right. Well, everyone in the Discord, or not the Discord, Zoom, have a fantastic
That's crazy. I've never seen this
before.
Errands?
Yeah, in person if you have the chance.
These things
Regardless. Bye.
Bye.
I have no idea. Is he a vlogger? I have no idea.
Oh, you're not on the camera.
Hold on. There.
Yes.
He's a streamer. Really?
Fantastically.
Oh yeah, he streams.
See you online.
He's server stream. But he doesn't vlog. So why does he have it?
Oh wait, that's the end of the meeting.
IRL streams.
Hey.
IRL.